Alright, this video is just giving you a demonstration of relating what we talked about with prisms yesterday to pyramids and cones. So look and pay attention to how many pyramids it takes to fill up this prism right now. It actually takes 3. So that's going to show you why there's an important part of our formulas today. Here's another prism. Notice they have the same height and the same base. So this is assuming if they have the same height and the same base. We want to know how many pyramids it takes to fill up the prism. What are your guesses? Well, it's more than one. Oh, it's not 2. This one is also exactly 3. Look at that water tension there. It takes 3 to fill it up, which you're going to see in the formula today. There's going to be a 1/3 just attached to the same formula as yesterday. Now let's look at what happens with a cone and a cylinder. Look at that. That one is also going to be exactly 3 cones to fill up the cylinder. So all we did to formulate the cone formula is we take 1/3 of the cylinder formula. So that's what you see on this page in terms of formulas. They look very similar to yesterday's, but both of them have a 1/3 in them. The only thing I want to stress is H refers to the height of the pyramid or the height of the cone, but it should be the straight up and down line, not the slant height. So H is this guy that goes from the vertex at the top and it goes straight down to the middle of the base. Remember this guy over here, he's called the slant height. We don't actually want to use the slant height when we're finding volume. We want to use the real height. Okay? So same thing for a cone. The height is going to be this one that's going straight up and down. This guy over here is what we call L. So just make sure you're using H and you're finding it when you need to. So first example is a pyramid. So I'm going to go ahead and write out the formula. Says 1/3 big B times H. So then I just need to find those two things. I need to know big B and I need to know H. Big B, remember, is the area of the base. I'm going to go ahead and highlight that. The base is this shape right here. They are all going to be regular pyramids, which means that base is actually a square right now, even though they didn't put the tick marks on it. They're all equal. So big B would just be 8 squared, which is 64. And then for this problem, they were nice, and they gave me that straight up and down height. The straight up and down height is 6, so H is 6. So then I'm just going to plug into the formula. That's going to be 1/3 of 64 times 6. I would just multiply those on your calculator, do 64 times 6, and then for the 1/3 part of it, you can just divide by 3. So I'm really just doing 64 times 6 divided by 3 to get the answer here, and that should be 128 meters cubed since we're doing volume. Okay? Alright, let's look at number 2. Same formula, 1/3 big B times H, so I need to know big B, and I need to know H. The base is again a square, so I'm just going to draw that down here. That's 18 and 18, so it's going to be 18 times 18 or 18 squared. So big B right now is 324. But then H is this line running down the middle. That's how you know how tall it is. It has to be the one that goes through the middle of the pyramid. We do not know that one, so we need to use the triangle here to help us figure that out. And just like we did when we were finding slant height, The 18 is if we went all the way across the square. This triangle we're trying to look at right now does not go all the way across, so make sure you take half of that. That's really going to be 9. So I'm just going to draw that over here to help me figure it out. So I have 9, and the hypotenuse is 41, and I'm trying to find h over here. So it's going to be 9 squared plus h squared equals 41 squared. That's 81 plus h squared equals 1681. And then if I subtract, I get 1600. And take the square root, h ends up being 40. And then we're just going to finish this off with the formula. Volume is 1/3 big B times h. And again, all I'm typing in is 324 times 40. Then divide it by 3 to take care of the 1/3. And you should get 4,320 centimeters cubed. Some of your volume answers will come out a little bit larger than maybe some of our surface area answers have come out in the past. So just a heads up. Alright, number 3 is also a pyramid, so we're still doing 1/3 big B times h. And I need to know big B and I need to know h. The part that makes this different is that this base is now a triangle. So that's what I need to find big B of. It's this triangle, and it happens to be an equilateral triangle. So I'm going to do 10 squared radical 3 over 4. It's going to be 100 divided by 4 is 25 radical 3. And then the h, if you look at where this is drawn, it's kind of drawn in an interesting position because it's outside. So that is measuring if we went straight down. Because it's outside and it's straight like that, it's not attached to it, but it's measuring from the bottom to the top. That is your height. Okay, if it were along the edge, we would have to figure it out, but we can use that if it's pulled outside of the figure and it's going straight up and down, you can use that as the height. So then the volume is going to be 1/3, 25 radical 3 times 6. And we're going to leave this with the radical in the answer. So what I need you to multiply on your calculator is 25 times 6, and then divide it by 3 to take care of the 1/3. So you should get 50 radical 3 inches cubed. Okay? Alright, the next one we're looking at is a cone. So that formula is 1/3 pi r squared h. So all I need to know in this picture right now is I need to know r and I need to know h. R is the radius, which would be halfway across here, which is 4. So r is 4. And then h is the line down the middle of the cone, which we do know right now h is 6. So I just have to plug those into the formula. That's 1/3 pi times 4 squared times 6. And then we're going to put everything in the calculator except for the pi. So you can do 4 squared times 6 first. That should end up being 96. And then you're going to divide that by 3. And you should get 32. And then we're going to leave the pi in the answer. 32 pi centimeters cubed. If you didn't try to type that in yet, please try that to make sure you can type that in correctly. And then one more cone here. For number 5, I need to know r and I need to know h. R they did already give me, that is the radius because it goes halfway, it's 4.8. But this time I don't have h. I need to know what h is for this particular problem. So I'm going to have to use Pythagorean theorem to figure that out. It's 4.8 squared plus h squared equal to the hypotenuse is 8 squared. 4.8 squared is 23.04. Give me that whole decimal. Equal to 64. And then we're going to subtract, and we get h squared is equal to 40.96. And then we're going to take the square root, and h is going to be actually a nice decimal, 6.4. Okay, then we need to finish finding the volume. Again, the formula is 1/3 pi r squared h. So that's going to be 1/3 pi times 4.8 squared times 6.4. And make sure you can calculate this properly on your calculator. You should get the volume is we'll just round that, 49.2 inches cubed. Oh, I didn't put the pi in there. Back. 49.2 pi inches cubed. Okay? Alright, then the last problem is just going to be a word problem. Just to practice this again, you should be trying these on each assignment because they're good application problems, and this is what the real world has. So imagine you are working in an office and your office cooler has cone-shaped cones with a depth of 6 inches and a diameter of 5 inches. This is what those would look like. I'm going to draw it upside down. I think you guys maybe hopefully have seen these before on a water cooler. It's like a snow cone holder. So they're telling you the depth is 6 and the diameter is 5. And they want to know if you fill your cup 3/4 of the way so you don't spill 5 times a day, what volume of water have you drank? So we know we're trying to find the volume here. That's 1/3 pi r squared h. And I can fill that in. R is going to be half of 5, so R is going to be 2.5. And the height is that depth of 6. And then I'm going to have you guys go ahead and put that in the calculator. So you get 12.5 pi if you put that in the calculator. But we have to recognize that this is a real world problem. So I want you to actually put the pi in your calculator to get what that is as a decimal. So I'm going to type in 12.5 pi. And that's 39 point, we'll round it to 3. Alright, so that would be what 1 whole cup would be. But we've got a couple other things we've got to break down here. So first off, it says we only fill the cup 3/4 of the way. So we need to do something, an operation with those that 3/4. You could set up a proportion if you wanted to. You could do 3/4 equals 39, or yeah, x over 39.5. I'm just going to take 3/4 of it, which means I need to multiply by 3/4. So that's what I'm going to do on the next step. So I'm just doing times 3 divided by 4 on my calculator. And you get 29.5. So that's how much 1 cup is. And then there's one other piece of information that's important, is it gets filled up 5 times a day. So we need to take that answer and multiply it by 5 to figure out how much volume of water is consumed each day. And you get 147.5. And that's going to be in inches, cubic inches of water. Okay? So it's really just taking the numbers that are there and thinking about what you need to do with them to get to that final answer. Sometimes you multiply, sometimes you divide, but you need to work with them to get to the answer. And that's just an important thing for you guys to know going into the ACT. You have a class kick to work on, and you have some problems to practice for homework.